Cherise pays the entrance fee to a museum, then buys souvenirs at the gift shop. The graph shows the relationship between the total amount she spends at the museum and the total amount she spends at the gift shop. Write an equation to represent the relationship.
Good. Okay, so you have to read the ordered pairs from the graph and use them to fill in the table. All right, they started it for you. If you look at the graph that's below the picture on your right, you can see they did the 0.05. So over 0 up 5. Over 5 up 10. When they go over 10, Nicholas Willoughby, how far did they go up? What did you put under the 10? Nicholas Willoughby, and you're muted, so you'll have to unmute to answer.
15.
Good. Over 10 up 15. And Nicholas, over 15 up. Go ahead. Keep going, Nicholas.
20.
And what did you put for the very last point?
I put 25. No, sorry, 20. And it would be 25.
Good. Those are the points. And then it's asking for what is the pattern. Matthew Bellino, what did you put for B? What's the pattern here? You have to unmute, Matthew.
It multiplies by 5 every time for the total amount.
Okay, I get the 5, but take a look. Is it multiplying or is it
adding?
Yeah,
adding.
Good. So the total amount is 5 more than the gift shop amount every time. Good. We're adding 5. Part C wants us to write an equation to represent that. Nicholas Marks, for part C, what did you put for your equation? That's going to be the y equals
5 plus x.
Good. 5 plus x or x plus 5. Okay. The next section, we have to identify the dependent and independent variables. Cassie, what did you put for dependent and independent?
For the dependent variable, I did the total amount. For the gift shop amount, I did independent variable.
Good job. The x-axis is always your independent. Good job. Okay. One more question. You had to draw a line through the points and connect those. Find the point that represents Cherise spending $18 and use it to find out the total if she spent $18 at the gift shop. Then use your equation from C to verify. So then we need to look at the chart, go over 18, see how far you go up, and see if that works in the equation. Nathan, what point goes with, or what y value goes with x is 18?
$23.
Good.
If you would fill in the variables, it'd be $23 equals $18 plus $5.
And that is true, so it does work. Okay, good. Perfect. It works like that. That's going to be the basis of algebra as we move ahead. It's linear, so we're always talking about straight lines, and they always work out like that, so they're kind of fun to work with. Okay. I actually want you to go all the way to page 354. Because on page 353, they always do the work in this middle column, which I think is confusing. So we're going to go right to the guided practice to start, because I think you can do that. Okay. We're going to look at page 354, the guided practice. So it's talking about Frank mows lawns in the summer to earn extra money, and he can mow 3 lawns every hour that he works. Okay. They want us to make a table to show the relationship between the number of hours he works and the number of lawns he mows. And then graph it. Okay. So you guys have a chart in your book, and it says hours worked and then lawns mowed. Like, how many lawns can he mow? Okay. They started out for you with a 0 and a 1. Okay. So you guys are looking in your book, and it looks like this. You might want to pin me so you can see my board. Okay. Serena, if he works 0 hours, if he doesn't work at all, how many lawns will he mow? What do you think? Oh, Serena, you're muted.
To 0 lawns.
Yes.
0 lawns.
0. If he doesn't work, he doesn't mow any lawns. So we're going to put a 0 there, and we're going to plot the point 0, 0. So go to your graph and put a point at 0, 0. Along your x-axis, though, write hours worked because it doesn't have a title. So along the x-axis where it goes 1, 2, 3, 4, 5, write in hours worked. Okay, so do that now. And then along the y-axis, it's going up 2, 4, 6, 8, 10, write lawns mowed. Okay, so across the bottom, you have hours worked. And going up, you have lawns mowed. And you graphed the point 0, 0. Okay, so Serena, we have to go on. If he works 1 hour, how many lawns does he mow?
2.
We'll look in the story. How many does it say he could do every hour?
X.
Go up above number 1 where it talks about Frank mowing lawns. It
Oh,
says
3.
3. So if he works 1 hour, it's going to be 3 lawns. So put that in your chart and plot the point 1, 3. Okay. And then in the chart, we're going to add hours 2 and hours 3. Okay. And Serena, we're going to keep going. 2 hours worked. How many lawns is that, Serena?
6.
Good. And how many for 3 hours worked?
9.
Excellent. Okay. You're going to fill in your chart and plot those points. Okay. So you plotted 0, 0, 1, 3, 2, 6, and 3, 9. If you look at them, they should look like they would form a straight line.
Yep.
Okay. And we have to write an equation. Matthew Bellino, can you help me with the equation? I'm going to start it with y equals. So your hours worked is like your x. Okay. Look in your chart. The first column is your x. The second column is your y. So we go from 1 to 3, 2 to 6, 3 to 9. What are we doing to that first value to get the second one?
Am I muted?
Nope, I can hear you.
Okay. You multiply 3.
Yeah, good. Multiply by 3.
Times the y times the x.
Good. So y equals 3x is your equation. Good work. Y equals 3x. Okay. All right. We're going to look at number 2. Make a table to show the relationship. Plot the points in a line through them. We're graphing y equals 1.5x. Okay, we have to make the table. All right. So what they're just trying to show you here is, look at this table, just looks a little bit different. It's horizontal. It's okay. They're just showing you it's another way to do that. Okay. I'm just making one on my, okay. So you guys have a table, look something like that. Okay. Make a table to show the relationship. X is independent, right? So that means we can just choose our X's. So let's choose 0, 1, 2, 3, and write that straight across for our X's. Okay, our X is independent. Okay, 0, 1, 2, 3. Now we have to figure out our Y values. All right, Cassie, the equation is y equals 1.5x. That means 1.5 times x. Okay, so Cassie, make sure you're unmuted, and I'm going to have you help me with the y values. So what's going to go with 0? If I put in a 0 for x, y equals 1.5 times 0.
0.
Good. So y will be 0. Got it. What if I put in a 1 for x?
1.5.
Good. What if I put in a 2 for x?
3.0.
Good. We're going to do one more. What if I put in a 3?
4.5.
Yeah, good. Okay, so you filled in the chart. Now plot those points. Okay, you might think, how am I going to plot 1.5? But if you look at the way that they broke up the values going up your y-axis, they give you like 1 and then a hashtag, like a hash mark and a 2. And then a hash mark, the 3. So that hash mark is like the half part. So you could see where 1.5 is, where 4.5 is. Okay, so go ahead and plot those points and connect them. They should form a straight line if you plotted those correctly. Okay.
Yep, I did it.
Okay, good. Okay, number 4 says, how can a table represent an algebraic relationship between two variables? You don't have to write anything in there. I'll just tell you it. You would say something like, it shows pairs of values that make the relationship true. Okay, you don't have to write that in, but that's what it shows you. Okay. Let's see. Let's look at the next one. And Nicholas Marks, could you read me the story, Students at Mills Middle School?
Students at Mills Middle School are required to work a certain number of community service hours. The table shows the number of additional hours service. The additional hours several students worked beyond the required hours, as well as the total number of hours worked.
Okay, good. So we're going to look at number 5. It says, read the ordered pairs from the graph and make a table. Okay, we're making another table. And they want you to read the ordered pairs from the graph. So we're looking at the points and filling in the table. So now we were looking at a table and filling in points. That's what we did before. Now we're going to look at the points and put them in the table. Okay, so you have additional hours, that's your X. And you have total hours as your Y. And you have some points, okay? And as I'm looking at my points, it looks like if I go across my x-axis, I'm going to have a point where x is 0. And then I see 10, but there's a point even before 10 on that hash mark before. So that would be 5 because it's halfway between 0 and 10. So I'm going to make my x values 0, 5, 10, 15, and 20 across the top. Okay. So if you can see my board, I'm holding that up so you can see that. We have to fill in the total hours. Okay, Nathan, when x is 0, what is y?
When x is 0, y is 20.
Okay, so we're going to put that in. And I'm going to have you keep going, Nathan. What about when x is 5?
When x is 5, y is 25.
Okay, good. When x is 10?
30.
Good. When x is 15?
35.
And when x is 20?
40.
Boom, that's it. Good job. Okay. Number 6, write an equation that represents the total hours in terms of additional hours. So they're going to want us to write an equation, y equals, okay, because your total hours is y and your additional hours is x. So we're writing an equation of y in terms of x. Y equals x. Look at your chart. And are we consistently adding the same thing? Or are we consistently multiplying by the same thing? Consistently dividing by the same thing? I want everyone to fill in number 6 before I call on someone to answer. Write down what you think. Okay. Everybody write down what they think for number 6. And then I'm going to call for Nicholas Willoughby. So go ahead and unmute Nicholas W. and tell me what equation you wrote.
Y equals, I don't really get what it's asking. Just equation.
Yeah, they want you to look at the hours worked. So 0 goes with 20, 5 goes to 25, 10 to 30. What's happening there?
X plus 20.
Good. Every time we're adding 20. Perfect. So y equals x plus 20 is your equation. All right, number 7, we have to analyze this. How many community service hours are students required to work? Okay, in the directions that Nicholas M. read, it says the table shows, it says the students are required to work a certain number of hours, and the table shows the number of hours of additional hours several students worked beyond what they were required, as well as the total number. Can you tell how many community service hours they're required to work? Because this one wants you to look at the chart and say, can I answer that question? All right. If anybody thinks they know the answer, you can unmute and go ahead and tell us what you think.
There are 20 hours required.
Perfect. Yes. 20 hours is the answer for number 7. All right. They're asking, how many community service hours are students required to work? 20 is correct. Why did you pick 20, Nathan?
Well, I used the table. It says if additional hours are 20, then total hours. Wait, no. If additional hours are 0, then total hours are 20.
Right, good. So when 0 additional hours are worked, the total is 20. So that means you have to work 20 hours. And then some people must have enjoyed the community service so much they did some extra, even though they didn't have to. Okay. All right, you guys are doing a very nice job, okay, with working with 2 variables. I'm going to have you do numbers 8 through 11. And page 357. Okay, which is just like a review of this section. There's not a ton of problems on either of those, so it won't be too bad.
We don't have class tomorrow, right?
Right. So you guys do not have class tomorrow or Friday or Monday.
Because on the calendar it said that we had a couple classes.
Well, for Easter, there's what I want you to work on. Okay, and your Sum Dog Challenge. Some of you are finished. All right.
Thank you, my card.
And your card. I think Serena, I got yours, right?
Mhm.
Your card. Did you send me that? Okay. So I have a couple of cards, but also work on your essential workers card. And I'm sending those all in to Mr. Gilger. You guys will send them to me. I'll bundle all yours and send them to Mr. Gilger. He'll get everyone's and send them to Father Marco. Okay.
Thank you.
All right. Happy Easter, guys.
Thank you. Bye.
Bye-bye.